your ear, if they say, oh, if they shout, then what you feel? You will get irritated, no? And you may get pain. You may get pain. Why it happens? Because inside the ear, no, we have a layer called as a diaphragm. So this particular thing, so constantly what will happen from the inside the body, and air will be pushing it this one. Then ear atmospheric pressure, P naught A, P naught S, P naught S. This is a diaphragm. Okay, there's a very thin layer which will which will sense the sound signal. When there is no disturbance, no, from inside, what happens, P naught S, the body will exert a force, and here the atmospheric pressure force, it will be better. If somebody speaks, then the sound wave will arrive. When the sound wave arrives, what will happen to pressure? Will vary, no, compression, rarefaction. The pressure will change. When pressure changes, P1 is greater than P naught S. Then what happens is the diaphragm will start vibrating. As it starts vibrating, it will convert mechanical vibrations into electrical signal and will given to the brain, and the brain will process it. Now, like this, if the pressure like this, what is the maximum intensity? No, 1 watt per meter square. As 1 watt per meter square intensity sound signal will come, no, the pressure will be maximum such that what happens, the diaphragm will almost, because how much it can oscillate, there's some gap is there, no, inside the ear, it can vibrate. It cannot go beyond this certain limit is given. If the diaphragm is pressed more than that, so what happens, definitely it will be get strained and will get a pain. Is it okay? No, if somebody shouts loudly in front of ear, no, will get a pain because the diaphragm will be pushed back more into the ear. There's certain limit is there. If it push more into the ear, there the layer will get compressed and will get a pain. That's what the tolerable sound for human ear, or pain threshold, what we can call this as. Pain threshold. Okay, got the idea, no? So any intensity greater than this will suffer a pain. Then what is the feeble sound for which a human ear will respond? Feeble sound for which a human ear 10 to power of minus 10 watt per meter square. See, not zero. 10 to power of minus 10 watt per meter square. If any sound signal whose intensity is less than this, the human ear will feel that as if no sound. It's not hearing any sound. So this is called like a feeble sound for which a human ear will respond. Or you can say like a feeble sound on output, or the lowest intensity sound signal for which human ear will respond. If the intensity of sound signal I minimum, the human ear says though sound signal enters into human ear, the human ear says that I'm not hearing anything. Got the idea? This one. So like this, what will happen? By varying intensity, what will happen? So these are the limits. Shall we say these are limit, upper limit? This is a lower limit. So now there is no zero, no? You can see that it's not like zero. Zero is not reference. The 10 to the power of minus 10 is reference. Okay, afterwards. If I make 1 watt, if I make from intensity of sound signal, from 1 watt, if I make 2 watt, I don't feel double. Are you getting now? I don't feel double. When I make the intensity from say like a 1, if I make it 100, no, then I feel it got double. So the human ear not respond for linear scale, it will respond for logarithmic scale. So to overcome this, what will happen? I will, the reason for that, from volume button, no, from 1 watt you make it 2 watt, you don't feel double. No? You don't feel it is a double. If you make it from, so like, so let's take 10 watt will take, from 10 watt, if you make it 100 watt, no, you don't feel double. So like a 10 watt, you make it 20 watt. You don't feel the sound signal got double. When you make from 10 watt to 100 watt, then you feel it got double. So the human ear, to what it responds? It responds for logarithmic scale, not linear scale. So therefore, to overcome that, what happen will bring a quantity called like a loudness of a signal here. So here I'll put it the human ear logarithmic scale. So for that purpose, I'll define loudness of sound signal. Symbol beta. This will be log 10 I by I naught. Okay, sir, why you're making I naught? This is what I naught. Because I should compare with, see, when I say I am, my height is 160 centimeter. With respect to what I'm 167, with respect to Qutub Minar, I am 160. No, with respect to 0 centimeter, I am 160. No, or in terms of feet, what we say, like a 5 feet 10 inches, we say. My height is 5 feet 10 inches. With respect to what, I'm 5 feet 10 inches. With respect to 0, I'm 5 feet 10 inches. Similarly, if I say the sound signal, what is the reference? Not 0. This is the reference. I is speaking loudly. With respect to ohm, with respect to I naught, we are comparing the sound signal, not with respect to 0. So therefore, 0 is not a reference, I naught is a reference, I brought it. I is the intensity of sound signal. The unit was bell. Since this is a very large unit, no, to make it small, deci, to make it small, what happened? I'll bring 1 by 10. Then I'll multiply by 10. So what is a dB? How you write decibel? I think this is what nowadays, no, you can see minus 10 dB, 5 dB, plus 10 dB. In the volume controls, nothing but the loudness you are controlling, not the intensity. Okay, now let's compare the scales. So we have two scales are there, intensity scale and loudness scale. So intensity. So in intensity scale, so that there's the intensity, watt per meter square. There's a loudness in decibels. So first 10 to power of, if the intensity of sound signal is 10 to power of minus 12, what will happen to the loudness? So we'll use this formula, beta equal to 10 log 10. I'll put 10, 10. Again, don't think that 10, 10, 9, it is so. It's a 10 log 10. Now, what is the intensity of sound signal? 10 to power of minus 12. How much will get it when you solve this one? I think will be 0, no? Log to the base 10. So this will be 1. Log 1, how much it should be? 0. So 0 dB. Then if intensity of sound signal is say 1 watt, let's calculate beta equal to 10 log 10.
Sir,
Yeah.
sir, I noticed 10 power minus 10, no, sir.
What I wrote? Oh, minus 12. Sorry. How much? Okay, yeah, it's simple. Minus 12. It's a. I didn't see it. Yeah. I'll shade it. It'll be easy for you. Okay. Thank you for correction. No, let me substitute this. Okay, this will be how much it will become 120 dB. Now I'll show calculation so that it will be easy for you. Huh? So this will become 10 to power of 12 dB. Log 10 to the base 10. This should be the 1. Okay, what is the value? If intensity of sound signal is 1 watt, then in dB it will be this much. Okay, let's see 10 to power of minus 10, how much it will be. No, this is individual. The calculations I'm putting in this way. Okay, let's go for the next one. What is the loudness of signal of intensity 10 to power of minus 10? Log 10, the intensity is how much? 10 to power of minus 10, 10 to power of minus 12. I think this will be 100 or 10 to power of 2. Shall we put in 20 dB? Intensity of sound signal is, if it is 100, what will happen? Beta is equal to so 10 to power of minus 8 it will come, no? 10 to power of 14, sorry. Okay, now what will be the intensity if it is less than 10 to power of minus 12? Anything will come. So let's see next part. Beta is equal to 10. Okay, let it come with 10 to power of minus 14. Lower than that. So this will be 10 to power of minus 2. 10 into minus 2 log 10. This will be 1 by 100, no? 1 by 100. So it will be, is it okay? Minus 20 dB. Yeah? Loudness can be negative also. Specifically, I brought it. Okay, now it's something very important thing, something related to our noise pollution nowadays, we say, no? Noise pollution. What do you mean by that? On an average, if we listen for a sound signal, the 120 dB means like a human ear. So what happened in a day? What happened? Like in ohm, what happened? 60 dB. At the most maximum 40 dB. 120 dB is the threshold, no? 60 or in a ohm, if you are staying, what happened? Your ohm will be calm. If the loudness is say 0, okay, well and good. If the 10 dB, 20 dB, 30 dB, okay, fine. So when you're measuring when you're purchasing any ohm nearby roadside, so what happened? We have a loudness meter. Just switch on that. If it shows 70, 80 or 120 dB like this, so definitely open. It's a sound pollution. Okay, very good house, everything fine. But what happens continuously when you are exposed to this much of sound, no? What is the problem? The diaphragm, okay, you may feel very happy, okay, for main road I got a house. But what is the problem? The diaphragm inside your ear will be continuously vibrating. It will be disturbing your brain. You'll not get peace of mind. Okay, 1 day, 2 day, 3 day afterwards, you'll get irritated. You don't get peace of mind. There's a reason. So now, okay, now some, okay, let's come for the our lifestyle. Some say like a, sir, without television I don't sleep. Okay, you'll switch on television, you'll switch on some songs, then we'll start sleeping. No, okay, when you sleep, tell me like a diaphragm, how do it come to know that you have slept? Any sound wave arrives there, so what it does, it is going to, it is going to maintain a pressure difference. No, if a sound wave signal arrives there, due to that music, there'll be some pressure variation, and due to the pressure variation, the force on diaphragm will be varying, and the diaphragm will be vibrate. If the diaphragm vibrates, what happen? It will make the brain to alert. So you may feel sleep, you are sleeping, but your brain, what happen, will be still processing that sound signal. So they'll become incomplete sleep. So when you are sleeping, switch off all mobiles, everything. There should not be any sound disturbance. The reason the diaphragm will come. So nowadays, I think nowadays, if you see, uh, if you have small kids in your home, hmm, TV will be on and the kid will be sleeping. So do you think that kid is sleeping? So the television sound signal which is coming, no, the sound coming from television, what happen? Will generate a sound and it will make the diaphragm to vibrate. The kid's diaphragm will be vibrating. The brain will be working. So how come you'll get a rest? So if a brain is not completely at rest, no, the organs will not grow. So these are the so-called educated. Huh? Kid will be sleeping and the TV will be on. All 24 hours TV if it is on, what will happen? Your diaphragm for 24 hours it will be vibrating with a high that one. So any problem is there'll be a problem. There'll be a problem. Am I right? Look at your televisions in your home. How many hours it is on? Okay, 4 hours, 5 hours, 6 hours, 24 hours. Music. Okay, sir, I love music. Okay, listen half an hour. Hours together listening music. That too now we have like a that earplugs, headphones, so many things are there. What you're doing, you are making your diaphragm, you're killing your diaphragm. This is the one best organ what we have. So the peace of mind, if the diaphragm will not vibrate, there's a peace of mind. If it vibrates, there's no peace of mind. Finish over. So it's very important. Like it's not that something like we should watch television for hours together. One movie over morning. Again we'll watch movie in the afternoon. Continuously we'll be listening, no, the sound signal. So we should avoid this one. Sir, we will avoid your teaching. Okay, it's left to you. If you get irritated, avoid it. The one which is essential for that particular thing, you have to hear. This is the meaning. It's an organ. Huh? If it doesn't stop, if stops working, gone, we can't hear anything. That's a big problem. So you have that one. So you love music. What is the according to science? Half an hour is what more than that you should not listen. Finish over. There's a maximum time permitted to listen music. Finish over that one. Switch off afterwards. So TV will be on and the music channel will be on and for hours together. Oh God, like God, I don't know, like non-science or nonsense. It is non-science or nonsense. It is now you understood. So therefore, what happened? The sound pollution is something very very dangerous one than air pollution nowadays. The sound pollution from where it is coming from our gadgets only, mobile, televisions. Hmm? So definitely when you are speaking, also speak gently. Don't shout. No, it will disturb others. Different. Speak gently. Okay, this is about the diaphragm. Okay, why we brought loudness? This is a logarithmic scale. This is a linear scale. The human ear responds for logarithmic scale. Now you come for this one. If the intensity of sound signal is 10, okay, I'm interested in this. Anybody, can you put anything this one? If I make it from 10 to 100, uh, anybody, 100, how much it will become? 240. For 10, 10 you give it. Okay, and 100 I think we have, no? Oh, 100, 140 is there, no? Yeah, yeah. Somebody give for 10.
130.
130.
Look at this one. when you made it, when you make it, what will happen? So like a under this 100 is 140, no? 10 is 130, that one. So when you make it from 10 to 100, what happen? You feel okay. This one. So we have increased 100 times. No, here it just increased by 10 times. Got the idea? So we do respond for logarithmic scale, not for linear scale. That's the conclusion. Okay, got the idea. So these are the some things are there. So let's get into the some numericals. I think enough theory I discussed. Let's get into the straight away numericals. So I do have, so as I point source of sound. So this will have a power P naught. So can you remember intensity idea? Somewhere we have discussed. Let me start here. So this is the source, loudspeaker or a point source of sound. This one, it is having a power P naught. Now, what is the intensity at a distance X? How you define intensity? Power flowing per unit area. So let me take 2 points. So there's a point 1. Let me indicate this X1. Okay, so now what will happen to loudness if I move away? So what is the power of source? So what is this? This is a point source of sound. So what is the expression for intensity? How you define? Power flowing per unit area. So what you should assume? You should assume a sphere, imaginary sphere. The power, the power flowing normally per unit area per unit time, or energy flowing per unit area per unit time is what we call that as a intensity. No? P naught is the power of a source. What is P naught? P naught will become power of a source. It's a point source. So it will send out signals in all directions radially. So then what is the intensity at a distance x will become this one. Similarly, what is the intensity at a distance x2? P naught by 4 pi x2 square. Okay, let's calculate loudness at point 1. 10 log 10 I1 by I naught. Beta 2 equal to 10 log 10 I2 by I naught. Beta 1 by beta 2, let me take this one. So log 10 okay, keep this one. So let me take difference beta 1 minus beta 2. Just I'm trying to explain some idea here. Log A minus log B, what you write it as. What is I1? P naught 4 pi x1 square. So that everything will get cancelled. So x2 by x1 whole square. So this will become 20 log 10 x2 by x1. Like this. So as you move away, what will happen to loudness? Loudness also will decrease. Then the difference in loudness, yes, we can use this formula. If they ask you, so log A by log B, there's a one formula they may ask you. So ratio of the loudness, here the difference in loudness. So as we move away, so the loudness will decrease here. So here the expression will be beta 2 equal to beta 1. Got the idea, no? This will be, so what will be the loudness at 2 will be loudness at 1 minus of that one, you can say. So as I move away, what will happen to loudness of a signal will in fact decrease. That's what you mean to say. The loudness of signal will decrease as I move away. Any doubt if you have, you can clarify. I'll take the some set of numericals. For point source, we are able to tell intensity. Only for a point source, we know intensity. So we are taking help of this condition. Loudness at any distance. So you initially x naught, you can see this one. Initially the distance r. Then as you move away, the distance will increase. So what happened to loudness as x2 will become, say x1 is the one fixed value. As you keep on move away, x2 will increase, no? This quantity will increase. So what happened to loudness will become less. So as we move away from a point source, what happened to intensity of sound signal will decreases, loudness also decreases. That's what I mean to say here. Okay, this is about the basic idea of a loudness. So we'll take the sum, discuss some numericals related to the speed of sound. Time we have 50 minutes. We'll